We're going to have our last presentation by Mathias Thoenig from the HEC, the University of Lausanne, 8 and 8 Climate Security and Farmer Herder Conflict in Africa, which is related to the first paper.
Okay, excellent. So thank you for inviting me and for giving me the opportunity to present this paper. It's a paper written with Ulrich Eberle from Princeton University and the International Crisis Group, and with my colleague in Lausanne, Dominique Ronner. So, well, given the previous presentation by Nathan, I think there is no need, right, to insist too much on motivating why it is important to look at farmer-herder violence in modern Africa. Maybe let me just tell you what is specific to our approach and paper. First, we conduct a spatial approach where we focus on violence taking place really at the borders between ethnic communities of farmers and herders. And we call those border areas mixed settlement in the rest of the analysis. And it turns out that when you look at those, in the raw data, you can see that those mixed settlement areas are very violent. So 1/3 of overall fatalities in the past 3 decades in Africa actually took place in mixed settlement areas. And when you look at the spatial distribution of those mixed settlement areas, a lot of them are located in Sahel, but not all of them. Okay, so we're going to talk about Sahel, but also beyond Sahel. We're going to talk about other areas. And the second, difference in our approach is that we want to prospectively quantify how climate change will impact farmer-herder violence in the coming decades. And this is why we primarily focus on temperature shocks and temperature data rather than rainfalls, because it turns out that there are reliable prospective projections for temperature. For rainfall, it's a bit more difficult to get reliable projections. So the overall objective of our paper is to identify, areas within countries in Africa that will be particularly vulnerable to climate change in the future, and with the ultimate idea of informing policy interventions about the places that should be targeted. So in one slide, let me tell you what we do in the paper and what we find. So on the left map, we take temperature shocks that has to be interpreted as yearly deviations with respect to the historical average of temperature. And we want to look at how those temperature shocks translate into violence, comparing areas of mixed settlements, populated by farmers and herders, that are those pink cells on this map, that we compare to what happens on violence in areas that are populated either only by settlers in green or either populated only by nomads in blue. And then once we have estimated the model, we want to project what will happen at the horizon of 2040 using a series of different scenarios of climate change. And so what we find is, first we find strong evidence of farmer-herder rivalries. We find that quantitatively that a 1 degree increase in temperature leads to an increase of conflict frequency of 54 percentage points in areas with mixed settlement, compared to 17% in cells that are populated only by settlers or only by farmers. Okay, so it's a 3 times larger effect. We also find that those farmer-herder rivalries will exacerbate the detrimental consequences of climate change. So we find that the projected climate change scenarios by 2040 will increase future conflict, should increase future conflict by 26 percentage points if there were no mixed settlement in Africa. And once you take into account the presence of those mixed settlements, actually you find that the effect increased a lot. It increased up to 33 percentage points. Okay, so the detrimental effect of climate change will be exacerbated because of farmer rivalries. And then we document the drivers of those rivalries, and we find evidence in favor of resource competition. Right. Okay, so so we start with a grid of Africa. Now you're getting used to this kind of gridded map of Africa that is divided in 9,600 cells of 0.5 per 0.5 degree. we're covering the years from 1997 to 2014, and we cover 52 countries. So the conflict data come from the ACLED, the Armed Conflict Location Events data, and we consider violence as being violence related to riots, violence against civilians, and battles. And you'll see we make use of a specific feature of ACLED, which is the fact that we have elements of context. You know, in ACLED, you have information about describing what is the nature of violence. And so we can retrieve keywords that relate to disputes over lands, disputes over cows, over cattle, etc., to code violence that is specifically related to land disputes. Okay, so the temperature data are quite standard. They come from the Climate Research Unit, and the population settlement data come from the Murlock Ethnographic Atlas that we merged with Greg. And so we end up with our main explanatory variable, which is mixed settlement, which is an indicator function coding for cells that are populated by at least one nomad group and at least one settler group. Okay, so here on the right map, you have the spatial distribution in pink of those mixed settlements, as I told you, and you can correlate those, the population settlements with geographic feature. And what you get is that cells that are populated in green only by settlers tend to be cells with high quality of agricultural land, with a high level of NDVI, which is a measure of vegetation strength, and no infertile soil. By contrast, cells that are populated by nomads tend to be of poorer quality in terms of agricultural land, to have less vegetation cover, and to be very infertile. And those mixed settlements, that are populated by both nomads, farmers and herders, are intermediate, in the intermediate range in terms of geographical feature. This map depicts the spatial distribution of violence over the 1997-2014 period, and you see that there is a clustering of violence along the Sahel band, but not only in Sahel. If you look at descriptive stats, you find that the unconditional probability of observing an incidence of conflict is equal to 9% in mixed settlement areas and 7.8% in non-mixed cells. Okay, so and the difference is statistically meaningful. So even already in looking at the raw data, the unconditional evidence, you find evidence that actually those mixed settlement cells are more violent. Okay, so let's turn to our main specification. It's an OLS, a linear probability model, where we regress on the left-hand side the incidence of a violent event in cell K year T on the temperature, the average temperature in cell K during year T, and the interaction of this temperature with our main explanatory variable, which is the Denis coding for mixed settlement. What is important here is that we saturate the model with cell fixed effects and country year fixed effects, and so that's important in terms of causal analysis. But also another implication is that given that we control for cell fixed effect, those temperature here have to be interpreted as deviation with respect to the historical mean. So our main coefficient of interest here is beta, the coefficient of the interaction term. Okay, so we cluster we spatially cluster standard errors. It's very important in this type of setting, and I skip the details, but it's something I'm insisting on because it quite affects the results if you don't do that. Okay, so this is our main table of results, and let's focus on column 2. What you see here is that the coefficient of interest, the interaction term between temperature and mixed settlement, is positive and statistically significant, and is twice larger than the linear term, the coefficient of the temperature shock. And if you compare them to the sample mean of the dependent variable, which is the average frequency of violence across all those cells, you find that actually a 1 degree percentage point, a 1 degree increase in temperature translates into a 54 percentage point increase in frequency in mixed settlement areas, but only translates into only a 17 percentage point increase in non-mixed cells. Now, what is important here as well is that in columns 3, 4, 5, we also control for the interaction between temperature and a measure of polarization, ethnic polarization at the cell level. Okay, so because we know from the literature, you know, that ethnic polarization is an important driver of violence. And so what it tells us is that our main, you know, our mechanism, our coefficient of interest is robust to including the interaction with polarization, which means that there is something specific about the farmer-herder relationship here. Huh? On top of ethnic polarization, there is something specific about farmer-herder interactions. So the bottom panel here is a series of specifications that replicate the upper panel, except that the dependent variable is specific. So we now on the left-hand side, we have violent events that specifically relate to disputes over land. Okay, and what you see is that the coefficient of interest, the interaction term here, is robust and statistically significant. At first sight, it's true that the absolute magnitude of the coefficient is smaller than in the upper panel, but actually when you compare it to the sample mean, which is also lower, you find that the relative magnitude is larger. And here, if you make the back of the envelope computation, you will find that a 1 degree Celsius increase in temperature will increase land-related violence by 72 percentage points, okay, which is much larger than what you find with overall violence. Okay, so this is the first piece of evidence that actually farmer-herder violence is related to disputes over resources and over land. Okay, then we turn to the prospective study. We consider a vast array of different scenarios of climate change at the horizon of 2040, and using our estimates, we are able to compute the future change or the future increase in violence, taking into account those farmer-herder rivalries. And we can compute this future level of violence at the continental level in Africa, but also at the cell level, or even at the country level. And this allows us to highlight those areas or countries that will be more prone to violence in the next 2 decades. Okay, and here you see that Chad is unfortunately one of those countries. Okay, then those are all the robustness checks we conduct in the paper, so I skip them for the sake of time. Let me focus on channels briefly. So we want to contrast 2 channels, which are the main channels that have been discussed in the qualitative literature. So we first look at resource competition, right, as a candidate mechanism, with the idea that temperature shocks reduce supply of productive land, and this leads to overuse of remaining resources, and so that's a standard tragedy of the common argument, and this leads to conflict. And the reason being that the farmers, the farmers and herders use different production functions, if you want, different technologies. Some use farming, the other use grazing. And so we should expect that this channel of resource competition is active as the frontier between fertile lands and barren. Okay, so we should expect to observe this mechanism as the agricultural frontier. And in order to spot this agricultural frontier in the data, we define fringe as a dummy coding for the fact that the cell K is a cell that has a level of above median agricultural land and above median bare land. Okay, so it's really a mixed cell in terms of agricultural features. And then the second channel we consider relates to the cultural persistence of ethnic cleavages. And this channel should be active as soon as farmers and herders coexist. irrespective of the production technologies they use. And so we should expect that this channel is active in all cells for which the mixed settlement dummy is equal to 1. So how do we disentangle the two channels in our empirical analysis? Well, we exploit the fact that the agricultural frontier, so all those cells with fringe is equal to 1, and the ethnic groups borders, all those cells for which mixed settlement is equal to 1, do not systematically coincide. Okay, so on this map, in pink, you have all the mixed settlement, so you have the ethnic borders, whereas in white, you have cells for which fringe is equal to 1. So you have the agricultural frontier. Okay. And so how do we operationalize this thing? Well, we estimate the same model as before, but with a triple interaction where temperature and mix is now interacting on top of it with fringe. Okay. And this, you see that the coefficient is positive and statistically significant, which is indicative of the fact that, the competition of our resource is at work in the data. And if you compare the triple interaction to the double interaction term, you see that most of the effect, if not all, is actually channelized by the triple interaction term. So it's really indicative that what seems to be at play in the data when you want to explain farmer-herder violence is a story related to competition of our resources. Then we can have a look at climate-induced spread of violence by using ACLED data where we can trace, fighting groups, where they perpetrate their violence across the territory. And so then we can show that actually temperature in the ethnic homeland, so the larger is the temperature in the ethnic homeland of a fighting group, the further away out of the ethnic homeland this group will fight. Okay, and this effect of climate-induced violence, mobility of violence, sorry, or spread of violence, is observed only for nomadic groups. You don't observe that for settlers or farmers. Okay. Then we look at resilience through formal institutions. And basically what we find is that good governance, can fully curb farmer-herder violence. In particular, a high degree of democratization that echoes what Nathan has presented before, but also a high, robust mechanism for enforcing property rights are very efficient in curbing violence. And so the takeaway of this analysis is that political fragility is a precondition to climate fragility. In politically solid states or territories, you don't observe climate fragility. Okay, and this echoes what Antonio Guterres said, which is that it's not coincidence that 70% of the most climate vulnerable countries are also among the most politically and economically fragile. Okay, the way we operationalize that in the paper is that we go for interaction term, with those variables coding for, in particular, Polity4 for the democracy score, and for those are World Bank data, by the way, for the fact that there is a high level of land dispute resolution at the country. Okay, so as a conclusion, we find that erratic extreme weather patterns are at the core of farmer-herder violence when, well, in years with heat shocks, where, especially at margins of deserts, where arable soils is scarce. And why? It's because of resource competition. We also find that it's like climate change will exacerbate violence, farmer-herder violence in the future. But we also document resilience that is achievable thanks to good governance practices, and in particular practices related to enforcement of property rights and land dispute resolution. And I think we hope our analysis, if we push it a bit, will help in designing small-scale intervention, and in particular in informing those small-scale intervention about what territories are particularly vulnerable and should be targeted. Okay. Of course, the limitation of this paper is that we go for a large data set analysis. It's true that in reality, climate security is context-specific, And so we need to complement this type of analysis in the future with field-based analysis. And we plan to do so thanks to the crisis group.
All right, thank you so much. So we have a discussion from
Thanks a
Eoin.
lot. Yeah.
And we 5 minutes for discussion. We'll take 2 minutes after that and we'll wrap up. Go ahead, Eoin.
Let me unmute first, and then if I share my whole screen, let me see. Okay, can you see that now? Good. Okay, so thanks to the organizers for inviting me along, and thanks for the opportunity to read this great paper and to discuss it in this workshop. So at the risk of summarizing things a little bit too coarsely, let me just focus on some of the main stuff that's going on. So firstly, hotter temperatures increase conflict directly in these mixed areas where nomads and non-nomads are overlapping. And also hotter temperatures at the centroid of a nomadic territory are associated with conflict that happens farther away, okay? So the authors do this great sort of projection exercise that brings us such, not great news, which is that global warming is predicted to raise conflict by 1/4 in Africa in non-mixed zones and by 1/3 in mixed zones. And I think, this connects really well with Chris's point this morning, but they take this heterogeneity exercise very seriously and show us that the effect is likely going to be smaller in countries that have these attributes, right? So democracy, land dispute resolution, low corruption, and federal institutions. So obviously this is an important paper, it's a timely paper. I should say also that the authors have admirable taste in research topics. This is a very under-researched area. So more rigorous data intensive work like this is the more the merrier, really. So most of what I have to say is just sort of digging a little bit deeper into mechanisms and trying to figure out what exactly is going on. So my first comment relating to that is we sort of have these two findings, maybe separate findings, maybe not. So one is about the direct effect of temperature on conflict in mixed zones, and the other one is about the effect of temperature in the centroid of a territory on conflict farther away. So my first thought here is I think it'd be really interesting to see what happens when you allow for both of these in the one specification, right? So if temperature is correlated across space, which it is, then it's possible that one of these findings is just reflecting the other or vice versa. So if we look at the second one, for example, hotter temperatures at the centroid of a nomadic territory could be correlated with hotter temperatures farther away from the centroid of that territory, which could be directly leading to conflict over there. So I think one way to address this is to come up with a regression specification that allows for both simultaneously, and effectively then you're estimating one while holding the other one constant. I think that'd be really interesting to see. I think another reason why this combination would be interesting, and my apologies if I have this wrong, but I think the two analyses are using different samples. So the first one is based on all of Africa, and then the second one is sort of zooming in on the Sahel. So I think it'd be interesting to keep the sample constant between both and get a sense relatively, get a sense of which one is really driving what's going on. And then just a smaller note on this exercise. So nomadic territories tend to be larger. It'd be interesting to see how many of those clashes, those spillover clashes, are happening inside the nomadic territory versus outside. And I think in the Dinka example that Mathias just showed, it looked like very much it was happening outside, right? They're happening a fair distance away from the centroid. Okay, so one of the main sort of mechanism tests in the paper that Mathias just explained very nicely is this culture versus competition test. So just to recap, they define mixed using historical ethnographic data, and then fringe using contemporary agricultural or geographic data. And they find that the action is mostly happening in fringe and in the combination of fringe and mixed, and not so much in mixed alone. Okay, so this interpretation then is that conflict is not due to the mix of ethnic groups per se, and it must be due to rivalry over resources instead. So a couple of assumptions are necessary for that interpretation to sort of carry through. First is that fringe was once collinear with mixed. So mixed and fringe were once the same, but fringe has sort of crept because of global warming over time. So the difference between the two that we observe today is because of that creep in fringe over time. And then a connected assumption is that the mixed only areas still contain the same mix of settlers and nomads. Okay, so the populations didn't move with the fringe, they stayed put as the fringe moved. And I guess another assumption connected there would be that those who changed, at least one of the two groups, must have changed the economic activity, right? So a place that's formerly fringe now becomes agricultural. In that sense, the nomads should have converged to the settlers' production technology, or if the previous fringe is now bare land, or if it's more pastoral, then the settlers must have changed their economic activity. So I think it'd be really cool to dig into these assumptions a little more. So these mixed areas, according to Greg, they could be different to the fringe for other reasons, not just the creep over time of the fringe. Could be measurement error. It could be, some reasons that might be endogenous to conflict. I think it'd be interesting to see, use ethnologue data, which is newer, Murdoch map data, which is older, see if they all line up, all three of them, which would be consistent with the fact that the people don't move even if the fringe does. I think it'd be really cool to use microdata to see if these mixed only cells, right? So the leftover mixed cells that aren't fringe, do they still contain the same mix of ethnic groups as the combined areas? And even going further, and this might be tricky with Afrobarometer, but I think it'd be really cool to check the occupation data in these data sets to see if the main economic activities between the groups have converged now that the fringe is no longer there. And just generally speaking, I think it'd be cool to dig a little bit deeper into this idea that the geographic fringe was once collinear with borders, but has moved over time, because I think it's an interesting story. So some other tests that I just sort of came to mind when I was thinking about this, and they kind of bring me back to the title of the paper. Okay, so the title of the paper is Heat and Hate. Okay, so let's think about heat and hate. So heat is linked to conflict all over the world and throughout history, and it's associated with the fall of some civilizations. And they're linked at many different scales. So what do I mean by different scales? So heat increases road rage, heat increases police aggression, heat increases profanities on Twitter, heat increases the joy of destruction in lab games, and heat impairs cognitive function. Okay, so let's collectively call this observation 1. Observation 2, which has actually been mentioned a few times already today, is that there seems to be a lot more conflict at these ethnic borders in Africa relative to other areas, right? So grid cells that have these exact historical ethnic borders are 27 percentage points more likely to experience conflict. So what I think this paper is very well positioned to do, and I think what would be really interesting to see, is putting those two facts together. Okay, so do temperature shocks drive conflict at historical ethnic borders in Africa? So is it the case that temperature shocks exacerbate existing tensions between groups? And where this paper I think is really well placed is they could look at different definitions of mixed as well. So rather than just nomad versus non-nomad, think about other combinations of traits from the ethnographic atlas that are different on either side of the ethnic border. Okay, so you could do this systematically, and maybe then you could trace out, which combinations of traits give you similar results, which don't. Is there a pattern to this? Or are there certain economic traits that are rivalrous? Are there certain economic traits that are more complementary? Do temperature shocks affect conflict differently depending on those pairs of traits? I think that'd be a really interesting angle. Another simple thing one could do along the same sort of lines is you could have a new sort of universal mixed binary variable, which is just cells containing and overlapping Greg polygons or areas that have more than one ethnic group. So this would be a little bit different to the polarization control. It'd be more just an indicator equal to 1 if it's a mixed area, and try to get a sense, is that sort of average overall effect? How different is that to the nomad and non-nomad effect? And then one other sort of suggestion that again is probing down this heat and hate avenue is you could look at temperature on the day and location of an Afrobarometer survey and see if interethnic attitudes are different on hot days relative to cooler days. So overall, great stuff, really interesting. I'll wrap these slides up and send them to the authors with some other comments as well, and I'll hand it back to you, Remi.
Thank you. We have no time. I think Roland had one question. Roland, if you're still here, you can ask your question. And
I mean, that's just a subset of one of the questions that was asked, basically about robustness with other data, because the settlement pattern map looked kind of suspicious in the sense that mixed settlements were all along the borders between Morocco and Algeria, and along the borders of Algeria and Tunisia, and also all of Egypt. So I was just wondering whether there's some kind of data flaws that define some of the mixed settlements in Northern Africa. That was all.
All right, great. Because we really have no time, Mathias, take 1 minute to respond those.
Well, first, yeah, thanks, Eoin, for the great discussion. I wish you are one of our referees in the future, because you have no critique and only suggestions. So I think that's quite impressive, and they all make sense. I mean, and even for this paper or for the for a later paper, maybe a spin-off paper. Thanks a lot. Really, really constructive. I appreciate. So given that you have no specific critique, it does not call for any comments. Maybe just to address Roland's point, we were concerned with, in particular with Egypt, because all those pixels are clustered in Egypt. And so we exactly address your point by, in some robustness checks, we take away out of the sample North Egypt, and so we play with these things, right? So yeah, but results are robust. So I think it's not this type of it's not, maybe there are some concern with the data for Northern Africa, but they do not drive our results. Thanks.
Great. Well, okay. So thank you everyone for attending today. It has been an intense but productive workshop, hopefully. And I want to thank the events and operations team at IEP, especially Kai Renner, and same at the World Bank, especially Rogelio Ochoa. And hopefully we should do that again in the future. So thank you everyone, and we'll continue the conversation by email and all of that. Thank you.